Hello calculus, welcome back. Our objective today is going to be to find derivatives of inverse trig functions. I've got the checklist on the screen. I do have something new highlighted. I need you to have your derivatives reference sheet. Should look something like this, hopefully with this part filled out. If you don't have that on you, it is on the syllabus tab, so you can go ahead and pause this video, make sure to have that either written down or in another tab pulled up so that you have that for your reference, because we're going to look at the bottom part of that reference sheet today. Alright, so for derivatives of inverse trig functions is what we're looking at today. Before we again look at the calculus, let's do a little bit of a review of just the trig. So what is a inverse trig function? Well, let's start with what we know. Go ahead and write this with me. If I ask you what sine of pi over 4 is, that would be what? That would be square root of 2 over 2, right? You're going to the unit circle, grabbing the y coordinate at 45 degrees. Now, if I ask you for the inverse sine, you may see it written like this, sine inverse. And remember, for inverse functions, we switch our input and output. So inverse sine of root 2 over 2 is equal to pi over 4. See how I switched my x and y? Remember, you may also see inverse written as arc for angle. And you're giving me the angle. What is the angle when sine is equal to root 2 over 2? Okay? Now, as a reminder, and I know it's been a while, but for inverse sine and inverse tan, you look at quadrants 1 and 4. Okay, so this is for inverse sine of an angle and inverse tangent of an angle. This is so that you don't have an infinite number of answers, right? And for inverse cosine, it was restricted to quadrants 1 and 2. Okay, we're not going to be using this a whole lot. I just want to kind of remind you what even is an inverse trig function, and again, that's just when you're switching your input and your output. So if I wanted to know, for example, arc tan of 0, this would be for what angle is tangent equal to 0. Well, tangent is y over x, so here I've got the point, right, 1 comma 0, so that would be tangent would be 0, and this is the angle, 0 radians or 0 degrees. So just a quick little recap of inverse trig. All right, so let's look at those last 6 derivatives you have on the bottom of your reference sheet now. So let's look at them graphically from a calculus perspective. Let's see if we can match these first 3 inverse trig functions to their derivatives on the right-hand side, okay? So if I were trying to match these cards, so function to its derivative, I would honestly start with inverse secant here, option C. Why do you think I would start with that? Until that is the only discontinuous function, and there's only one discontinuous derivative, right? So C here must go to A there. Let's see if I can get a better view here. Let's do it this way. Okay. Notice that your original function, it goes from concave up to concave down, so the derivative should go from increase to decrease. Furthermore, your original function goes increase, increase, right? So your derivative function should be positive for the whole piece, which all 3 of these are, because notice all 3 of your red functions are increasing on their entire domain. Okay, so now that I've really matched those based on the discontinuity, let's try the other 2. So for this first graph, it goes concave down, concave up, right? So what should its derivative do? It should go decrease to increase. So based on the options that are left, would you choose capital A to go with little b or little c? It should go with little b because that graph goes decrease to increase. Okay, and then the last one, and we only have one left, capital B should go to little c, but notice again this goes concave up, concave down, so its derivative should go from what to what? Increase to decrease, so it goes here. Good deal. Now if you'll look at your reference sheet, we just matched the 3 of the inverse trig functions to their derivatives, right? These should match based on your reference sheet. All right, so I'm going to see if you can match these graphs on your own. Try to not look at your reference sheet. Notice that all 3 of the red graphs are decreasing on their entire domain, meaning all the derivatives should be what? Should be negative or below the x-axis. Good. So again, start with the one that has a discontinuity, and then work from there. I'm going to ask that you pause your screen, so go ahead and pause. Okay, hopefully you paused, and you got something like this. So again, match the one with a discontinuity, then take a look, like capital D goes concave up, concave down, so its derivative should go from what to what? Should go from increase to decrease. Capital E goes from concave what to what? Concave down to concave up, so its derivative should go from what to what? Decrease to increase. Good. So again, these are on your reference sheet. These were the first 3 we did. Notice all positives for their derivatives, right? These were the last 3 we did, and notice that they all start with a negative, very similar to the regular trig, right? If my original function, trig function, started with a c, the derivative started with a negative. So if you can, go find example 3 from the last lesson. So example 3 gave us f of x is tan x, and it asked us to find f inverse prime of 1. Okay? Well, what is the inverse of tan? It's arctan, or inverse tan. So its derivative formula is given right here. So if I were to plug in 1 into this equation right there, I would get 1 over 1 plus 1 squared, which is 1. So I'm getting 1 over 2, which is indeed what we got for example 3 last time. So these look intimidating, right? Let's talk about some tips for memorizing. We talked about one where basically if you've got these 3 memorized, then again, if you just put the co-function on it, it's the same but with a negative, right? So I've got sine and cosine. I've got tangent and cotangent. I've got secant and cosecant. So they're the same, just with a negative in front, okay? So I'm going to say, let's memorize this row. And in fact, I have never seen arcsecant or arccosecant on the AP exam, and I will not put one on the test. So I'm going to ask, please memorize those 2. Okay, those are the ones that pop up the most. So what are some tips? Well, as one of my high school math teachers said, it's the stupid things you remember. So let me give you some tips. If it starts with an S, think S for square root. And S for subtraction. Please write those. So see how sine and secant both have a square root? And they both have a minus, okay? So I'm looking at differences first, and we'll talk about similarities. All right, if it starts with T, arctan, the T looks like a what? Looks like a plus sign. So I have a plus here for arctan. Now for similarities, they all have 1 over something, right? And notice that for these 2, which are the 2 I want you to memorize, the 1 comes before the x squared, right? So remember, 1 comes before 2 on the number line. In other words, 1 and then your operation x squared. Okay, so just some tips for memorizing those. All right, I'm going to force a pause on your screen. Can you please copy example 1 for me? Okay, so we want to find arc the derivative of arc sine of 3x. Any special rules? We're going to need chain rule because I have arc sine of something other than just x, right? I have 3x. Now when you're doing these trig, inverse trig derivatives, I really recommend putting the derivative of just the parent function to the side so you've got it as reference, and also you are working on memorizing those, okay? So I have 1 over square root or no square root? Square root starts with an s, right? And then 1 first, or x squared first? Always 1, plus or minus, minus because subtraction, and then x squared, okay? So that's the derivative of the parent function only. So now we know we need chain rule, so I am going to replace, and anytime I see an x, I'm going to replace it with what? With 3x, replace it with the baby, right? And then don't forget to multiply by the derivative of the baby at the end, and the derivative of the inside is what? Is 3. Okay, so let's try this. So f prime of x, I'm going to come back to my derivative of the parent function there, but again, instead of x, I have to replace anytime I see an x with 3x, so that I'm just going to go ahead and put 9x squared. Are you good with that? Squaring 3x, and then times 3. And that's our answer. You will more commonly see that 3 in the numerator, so you will see it like this, and that's your final answer. Please, please, please now be careful. Square roots don't distribute, you all, okay? So this does not simplify to 1 minus 3x, all right? It's a square root, a power of 1/2. You can't just magically distribute that square root term by term, okay? So this is your final answer. All right, I'm going to force a pause on your screen. Go ahead and copy example 2, and then we'll do this together. Okay, so again, I highly recommend just writing the derivative of the parent function to the side here. So I've got arctan, so it's an inverse trig, so I know it's 1 over something. Square root or no square root? No square root. And I go 1 and then plus or minus for arctan. Plus, that t looks like a plus, and then x squared. So there's the derivative of just arctan, okay? Now how is this negative 3 going to impact it? Just going to come along for the ride, right? Any special rules? Chain rule again. Okay, so my inside is x over 2. Don't worry about that. Dividing by 2 is the same as multiplying by a half, right? So just think of that as 1/2 x. What's the derivative of 1/2 x? Just 1/2. So I'll be multiplying by the derivative of the inside at the end, which is 1/2, okay? All right, so let's come over here. Let's find g prime of x. Again, that negative 3 is going to come with me. Okay, then I'm going to come back to this orange piece here, but again, I'm replacing x with what? With x over 2. So when I square that, it'll be x squared over 4, right? Okay, so I have 1 over 1 plus, replacing that x with x over 2 gives me x squared over 4. Then times the derivative of the inside, which we said was 1/2. So just cleaning this up a little bit, I'll have negative 3 in the numerator. Let's bring this 2 to the front and then just keep this guy in parentheses, and we're going to leave our answer like that. All right, I'm going to force a pause on your screen. Please copy example 3 for me. So we want to write the equation of the tangent line. Again, as soon as I see that, I think, okay, point slope. Oh, how nice, they already gave me the point, right? So I just need to find the slope, in other words, the what? The derivative. I've got an inverse trig, so let's just write the derivative to the side here. Notice any special rules? No product, chain, or quotient, right? Just good old arc cotan. So think of the cofunction of tangent, right? So if I do the derivative of arctan, remember that's 1 over square root or no square root. No square root does not start with an s. And then 1 plus or minus for tan, plus, and then x squared. Now this is cotan, starts with a c, so the only difference is a negative there, right? So this is already y prime, correct? Because I don't have any special rules to add to this. Okay, so now let's go ahead and find the slope, which will be y prime evaluated at this x value, square root of 3. So anywhere I see an x, I'm replacing it with square root of 3. So I'm going to get negative 1 over 1 plus square root of 3 squared is just going to be regular 3, right? So I get negative 1/4 as my slope. So final answer in point slope form, I will have y minus pi over 6 times equals 1/4 times the quantity x minus square root of 3. Let's check that on Desmos. Okay, so here's the graph of our original function, arc cotan of x. Here is the point of tangency that we were interested in, right? And here is the answer we got, and that looks great, right? If I zoom in on that point of tangency, the blue and the red should start to look exactly the same. By the way, if I were to use this to make an estimation, I stayed close to that point of tangency. Would the blue be an underestimation or over? It would be an under due to the fact that the red is concave up. Good deal. Okay, you all. That is it for today. I will see you all next time.